Hello. This is a sort of a redo of the second video for section 3.4. This is the first video of examples. So this is MA 105 and MA 190, section 3.4. What I'm doing is I'm going to reuse the notes in the examples I did the first time, and I'm just going to kind of narrate and talk through it. I'll leave the old sort of soundless videos up. I don't know how it is that they lost their sound at some point. So those will still be up if you want just a silent sort of hand working through math problems experience, and then this will have sort of the explanations as we go. Not perfect, but I thought it maybe would be better than just sort of doing them again from scratch, since we've got the examples there, and in theory, they're pretty good. So I guess we'll see. Our first example, and I'll try to sort of cover up this little bit here. So sort of linear equation number one, negative 3x plus 18 is 0. The move here to solve this, right, what we're going to try to do is, combine like terms, group all the x's on one side, all the numbers on the other side. There's not really any like terms here to combine. This is about as short a one as we're going to see. So our step number one is going to be just to move, in this case, the 18 from the left-hand side to the right-hand side, right? So I'd like to get that. My goal is to get the x isolated by itself. What that means is I need to get 3x by itself first, negative 3x. So I want this 18 shifted to the other side. It's right, plus 18 here. So what's the opposite of adding 18 would be subtracting 18. So I can do the same thing to both sides of my equation, and I'm going to do the opposite of whatever is there, right? So if this is plus 18, I'm going to do a minus 18. I'm going to do the same thing to both sides. So that's essentially going to cancel the 18s from the left, and then I'll get my second line here, which would be sort of a negative 3x by itself, is equal to a negative 18. Also, you'll notice the notes are now in black and white versus color. The original notes, I had to reprint them, and my printer is black and white. So we've lost a little color here. We're sort of doing the opposite of the Wizard of Oz. So the next line, negative 3x equals negative 18. So the move here, right, we essentially have, something times x equals a number. That's kind of our goal. We're essentially one step from the end at that point. So all I need to do now is divide. You might be tempted to do a plus 3 to both sides because of the negative sign, but that's a negative 3, right, times x. It's not that we're subtracting 3. The 3x is kind of one thing. So I need to get the negative 3 canceled away, which means I'm really doing a division by negative 3. So I'll divide by the 3. We'll have the negative along for the ride. What will happen then, of course, right, is 18 divided by 3 is going to get us a 6, right? And then negative divided by negative, right? Two negatives stacked over each other will cancel, and they'll leave us with a positive value. So this is sort of a positive 1x, which we would just call x, right? Equals positive 6. And that's our solution, x equals 6. That's the idea. What I've done up here is you can check your work, right? So once you get a value for x as a solution, you can sub it in, x equals 6. So if we sub it, right, replace the x here in my equation. So negative 3 times 6, right, would be negative 18. And then that plus the 18 here would, in fact, get me the 0 that I'm after, right? So in the check, we're sort of saying, negative 3 times 6 plus 18, question mark equals 0. And the answer is, yeah, it does, right? The 18s would cancel, and you're good to go. So that's our first example. Shift this up a little bit and look at example number 2. So now I've got 7y minus 9y equals negative 10. This is now kind of, 3 different terms. The first one had 3 terms, but one of the terms, right, the whole right-hand side of the equation was a 0. Didn't have as much of an impact here. So now this is 7y minus 9y equals minus 10. So right off the bat, we have some like terms. We don't need to shift anything around as far as moving things from the left side to the right or vice versa. So I'm going to combine like terms by doing 7y minus 9y right off the bat, right? Combine like terms. 7 minus 9 would be -2. And then, right, -2 of what? So we have -2y. When we combine like terms, we're not going to change the variable, so it's going to still stay a y term. All we're doing is combining the coefficients, the numbers out in front. The -10 on the right-hand side is not doing anything. It's just along for the ride at this point, so we'll just sort of carry it down. Spoiler when my paper falls out of the way. So combine our like terms first, so then the next line is -2y equals -10. This is pretty similar to sort of where we were at this stage in the last one. -3x equals -18, right? So what we did there was divide by the -3. So that's going to be our same move here, right? So we'll divide by -2, that coefficient. Again, the negative is going to make you think maybe at first I should be adding a 2, but you have to keep in mind that, you know, it's a -2, but it's times the y, right? And so you're trying to undo, not the negative so much as you're trying to undo the relationship with the y value, with the variable. So if it's -2 times y, you're going to need to do a division by -2 to cancel it out. So the -2 over -2 would leave you with a positive y, right? Sort of a positive 1y as we have written here. And on the right-hand side, -10 divided by -2 is going to get us a positive 5. At this stage in the book, we haven't sort of gone through any fraction things. So one thing I'll say and sort of reiterate here is in this section of 3.4, all of your answers should be whole numbers, or, you know, positive or negative, right? So they could be integers, but you shouldn't expect any fractions or decimal style answers. If you're going through any of the problems, you know, in the book, and you end up with some sort of a fraction as your answer, something has gone wrong. There's been some sort of a small arithmetic mistake, maybe somewhere along the way. And you should go back and double check your work, because everything here should come out as a positive or negative whole number. In this case, y is 5, positive 5. Let's do one more a little bit longer. Shift this up into frame here. So this one is 6 plus 4b minus 8 equals -3b minus 11 plus 4b. So this is kind of 6 terms in total. We can sort of see on the left, we've got 2 number terms and 1 variable term. On the right, we've got 2 variable terms and 1 number term. So the strategy here is going to be combine like terms on each side first. There's versions of it where you could sort of move everything around as a step 1. I kind of like just combining first and simplifying it before I start shifting things around. That way I'm only really moving kind of 1 term over and 1 term sort of back, maybe at most. If you start to get it where you're moving, you know, 2, 3, 4, 5 things, you know, the more stuff you move, the more stuff you're keeping track of, it's just easier to potentially make a mistake. So when we combine like terms, right, we're just doing exactly what it says. So each side of this equation is its own expression. So what I'm doing is I'm saying, okay, so this is 6, and then this is sort of -8, right? So 6 minus 8 would leave me with a -2. And then the 4b is not like the other 2, right? One of these things is not like the other 2, and that's the 4b on this side. So the 4b is just along. We'll carry the addition down, right? So then our sort of line here would be -2 plus 4b. On the other side, you can see I've sort of done some circles underneath the b's because those are my like terms. So this is a -3b and a plus 4b. So -3 and plus 4 would sort of get me a positive 1b, right? You could just write this as b, and then the -11 is here. I have it sort of written as +1 just kind of for emphasis. It really is just sort of whatever you're more comfortable with. From there, what we're going to do now is, so shift our terms around. We'd like to get all the b terms on one side, right, the variable terms, and we'd like to get all the numbers on the other. In this case, usually my kind of preference is to try to shift everything so I get a positive value on my variable term. You know, in theory, it's kind of arbitrary. It doesn't really matter. So in this case, what I'm going to do is I'm going to say, so 4b is here as positive. If I want to do 1b over, I would subtract 1b away, and that would leave me with 3b. So I'll do sort of the b's to the left, so -1b from both sides. So this cancels from the right, and then you can see here, whoops, it will be positive 3b on the left. If we're taking our b's to the left, then that means we're taking our numbers to the right, our number terms to the right. So minus 2 on the left, we're going to add 2 to cancel it out. And then the same thing on the other side, we're going to add 2, right, combined with this sort of minus 11. Minus 11 and plus 2 would leave us at minus 9. So we're kind of at one more step to solve it in this case. Whoop, sorry, I got a little bit off center. So plus 3b equals negative 9. So the last step to solve it is going to be the same thing we've been doing. Divide by whatever our coefficient is. In this case, positive 3. So just divide by 3. Divide by 3 on both sides. That's going to get me right. 3 over 3 is 1b. And then negative 9 over 3 would be negative 3. And that's going to be my solution. Right? So that's our sort of solving linear equations part 2 with sound. So those are our examples. I'll have another video coming up after this that's going to be the part 2 examples from the old video, but again, narrated over with sound, so you get the explanations as you go.